Okay, we're going to look at a few from section 1.4, starting with number 2. We'll do number 3 and 4 as well. We have a figure that's given. It's basically the unit circle in the when you're looking at Achieve. This unit circle will be provided on the test. I'm going to show you what you'll have on the test here in just a minute. But we're going to use that figure to identify all the angles between 0 and 2 pi, or all the real numbers between 0 and 2 pi, satisfying this equation here, tangent theta equal to square root of 3. So when is tangent equal to square root of 3? And so this skill is real important when you're solving trig equations, and we'll be doing that a lot in the course. So lots of ways this can be done. I mean, the trigonometry that we're going to be using can be summarized with this sheet right here. This is one of basically 2 sheets. Usually I'll print it on front and back that I give you. One side has algebra help with information about how to write lines, equations of circles, all your laws of exponents that are real important. It has special factorizations, including the sum and difference of cubes. It has the quadratic formula if you need it, as well as some other facts, some geometry here as well at the bottom, Pythagorean theorem there as well. And then on the other side will be the trigonometry. So you'll have all your right triangle definitions. If you remember SOHCAHTOA, or however you remember that, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and so on. And then extending them to circular definitions here. And then finally, the unit circle itself. So you should be familiar with the unit circle and how to use this to get the exact value of sine, cosine, tangent, secant, cosecant, and cotangent for those special angles or special values. You also will have all the identities, all the fundamental identities. You certainly should be familiar with the Pythagorean identity. We probably don't use too much, but law of sines, law of cosines, addition, subtraction formulas, and double angle formulas can come into play sometimes. So they're all here as well. And you also will have the graphs of the 6 trig functions. So you'll have a lot of information on the tests when you take it. You'll have all this information. So let's go back to the question. Basically, it's saying use the figure, which is the unit circle, to find when tangent theta is square root of 3. Okay, so when we look at the unit circle here, and it's kind of hard to see a little bit there. I'm going to zoom in just a bit. You have all these ordered pairs, right? So how are we getting that? Well, in the unit circle, the value of r, which we're coming from these trigonometric definitions, the value of r is equal to 1. And notice that the sine of theta is y over 1 in that case. So that's the value of y, is sine of theta. In fact, this y coordinate here would be sine of theta if the value of r is 1. Do you see that? And of course, cosine theta is this going to be the x coordinate when r is 1. So these ordered pairs, the x coordinate is the cosine of the given angle, the y value is the sine. So you should remember, deriving that and showing how that works from trigonometry. Now, that gives me sine and cosine. Well, what about tangent? Well, the relationships, you can see tangent is y divided by x, but that comes from the fact that we know tangent is the sine of theta divided by cosine theta. That's the ratio identity, very important. And so once I have sine and cosine, I can find tangent. And once I have sine and cosine, I can also find secant, which is just the reciprocal of cosine, cosecant, which is the reciprocal of sine, and of course cotangent is the reciprocal of tangent. And so once you get sine and cosine, you've got all basically the 6 values there, the other 6, all 6 trig function values, I should say. Okay, so going back to this question then, when is the tangent theta equal to square root of 3? Well, again, tangent theta is sine theta over cosine theta. So you have to look at this ratio to find out when it's equal to the square root of 3. And looking at this unit circle, we see at pi over 3, the value of sine of theta, remember, the y coordinate, is square root of 3 over 2, and the value of cosine of pi over 3 is 1/2. And so sine divided by cosine, square root of 3 over 2 divided by 1/2, is indeed the square root of 3. So that's what we observe at pi over 3. Sine of theta and cosine of theta are those values. So the tangent of theta, tangent of pi over 3, is going to be equal to the square root of 3. But that's not the only place, right, where tangent will be equal to the square root of 3, because if I basically do a diagonal through the unit circle, come back down here to 4 pi over 3, the values of sine and cosine are both negative, right? Remember, the values of sine are positive in the first and second quadrant, right? Because they're the y coordinate, and y is positive above the x-axis. Sine is negative down in the third and fourth quadrants because the y coordinate is negative. Cosine's positive in the first and fourth quadrants where the x coordinate is positive, and negative back here in quadrants 2 and 3. So 4 pi over 3, sine and cosine are both negative, but a negative divided by a negative is still positive. So negative square root of 3 over 2, which is sine of 4 pi over 3, divided by cosine of 4 pi over 3, negative 1/2, is positive square root of 3. So when I'm doing my solutions, I'll usually just draw a picture of the unit circle and mark the angles where I know that they're going to give you the values needed. So pi over 3 and 4 pi over 3 are the two values. Make sure you note the instructions for expressing answers. They're listed in the parentheses. So you have to list your answers separated by a comma. You have to give exact values using, of course, the pi symbol, and write it in fraction form. You can't give approximations for these. Okay. In 1.4, number 3, we're to find all the solutions to the equation sine of x equal 1/2 on the interval 0 to 2 pi. Well, this is actually going to be pretty easy. When is sine of x equal to 1/2? We're looking for the y coordinate to be equal to 1/2. So right here, and that kind of makes sense. If you look at the y coordinate at this point, it's halfway, right? About halfway. That's 0, 1. So right there, it's going to be 1/2. And so pi over 6 is one angle or one value where the sine is 1/2. But where else? So if I continue to go across, I'm also 1/2 at 5 pi over 6, right? We can see that there. Okay, so sine is equal to positive 1/2 at pi over 6 and 5 pi over 6. Again, I would just draw the picture like this, indicating those two values, and that is the answer. I think in this one, you actually it's just a multiple choice one. But make sure you understand where this comes from. Okay. Number 4 says find all the solutions to the equation cosine of x equal negative 1/2. So now I'm looking for when cosine of x, remember that's the x coordinate. Don't be confused, by the way. The x here, sine of x, and the x here, cosine of x, is not the x coordinate on the unit circle. The x in that case would be these values of 0, pi over 6, pi over 4, pi over 3, and so on. The actual angle values, if you will. Okay, so it gets a little confusing, I know, but they're different x's. They're not the same. But the cosine then is the x coordinate on the unit circle, x coordinate. And so when is it negative 1/2? Well, it's positive 1/2 here. So if we go down, go back here rather, we're negative 1/2, and go down, we're still positive 1/2. So positive 1/2 at pi over 3 and 5 pi over 3, negative 1/2 at 2 pi over 3, and down here at 4 pi over 3. So that's when the cosine is negative 1/2 at those points. So you should be able to find the equation of the solution to any trig equation where it's cosine of x equals something, sine of x equals something, tangent of x equals something, if it indeed is one of our special values. So I mean, we're looking at these values in the ordered pairs. If it was something other than negative 1/2, like negative 0.4 or something like that, when is cosine of x equal to negative 0.4, right? 4/10, that's not on the unit circle. Then you'd have to use the inverse cosine or arc cosine function to help approximate the solution. Okay, so hopefully that's familiar. This sheet, by the way, is found in the resource module, the resources module in Brightspace. So this is what you'll have on test. If you want to get that, you can open it up or print it out, whatever, have that handy when you're doing your homework. That would probably be helpful. Okay, hope that's helpful.